Let me show you first why Flexeserve Zone is the #1 heated display. Our unique hot air recirculation technology is implemented in a way that makes this unit the global market leader in performance. This is how our hot air recirculation works. Firstly, you'll notice each shelf can be independently controlled and adjusted, and what makes it truly unique within the market is that the zones are thermally independent. Other units that claim to have individual shelf temperatures have no thermal barriers between their shelves. This means that heat transfer between the shelves is inevitable and temperatures are unreliable. Now you may think the fans within the unit are blowing hot air. Actually, they're drawing it in, causing the same air to continuously circulate within each zone. This circulation creates a tight air curtain, and that's why you can't feel any heat escaping from the unit, which you do with many other heated displays. Here we have a fully merchandised unit with each zone set to a different temperature tailored specifically to each food category. Now when you approach the unit, and even when standing directly in front of it, you'll realise you can feel no heat coming from Flexeserve Zone. It's only when you put your hand inside a zone you can feel a consistent air temperature throughout that three-dimensional space. This also means products can be double or even triple stacked because they are surrounded by hot air top to bottom with no hot or cold spots. Now I mentioned a consistent air temperature, and that's really important. With our technology, food is kept at the appropriate temperature through convection, and this is highly effective in keeping a product's temperature consistent. Many hot holding systems rely on outdated methods of keeping food warm, most commonly surface heating, which uses conduction. In the diagram, you'll see that the hot shelf puts heat through the food by direct contact. The bottom of the product is far hotter than the desired core temperature in order to keep the overall product above temperature. The temperature throughout this product is not consistent. It is significantly warmer at the bottom than it is at the top. This excessive heat causes moisture within the product to rise and escape into the packaging in the form of water vapour. This leads to dried out, toasted bottoms, which no longer allow heat to effectively flow, as well as soggy tops, as the moisture condenses inside the top of the packaging and then re-enters the product. All this additional cooking is a symptom of the excessive energy consumption of this method of hot holding. Surface heating is very inefficient because heating elements have to reach a far higher temperature than the products you're trying to hot hold. Not only that, but this method also loses a significant amount of energy to the surrounding environment. That's wasted energy that you pay for. Double stacking is also completely inappropriate for this method. Again, if you look at the diagram on your screen, you'll see that the necessary energy to keep the food at temperature is unable to travel through the first layer of products into the second one. This is because heat is unable to travel sufficiently, with that bottom layer of products acting effectively as an insulator. In this situation, proteins can drop below temperature, representing a safety concern and, of course, dissatisfied customers. In the case of radiant heat, we see a similar impact upon the product as in conduction, but in reverse. With this approach, heat is driven into the product from above using infrared emitters. Now with infrared, a significant amount of energy generated simply reflects off the packaging and into the air. This is incredibly inefficient. However, some energy is absorbed by the packaging, which then re-emits into the product. With this directional heat transfer, part of the product has to be heated beyond the desired core temperature, just as with conduction. So you can see in the diagram on your screen that the top of the product is very hot, the centre being colder, and the bottom colder still. This means we have another situation where multiple temperatures exist within product, rather than a consistent one throughout. Once again, double stacking is not an option, with the product that is the furthest from the energy source growing cold. The top products, which are now elevated and very close to the infrared emitters, become very hot. In fact, they are likely to be significantly overheated. Despite the temperature of that top layer, heat is not being transferred to the products below. So now you can begin to see why these methods fall short of true hot holding. And combining them doesn't help much either. Indeed, it's actually the worst of both worlds. When using surface heat conduction and infrared radiant heat together, both the top and bottom of the product are simply hotter than they need to be. This causes quality issues throughout the product. The top and bottom of the bun and the protein, which is the most important thing to keep hot, may actually be below temperature. With these methods, food quality suffers because product temperatures are not consistent throughout. Even in units with supplementary air, the situation is not significantly improved, and ultimately they are not comparable to a true convection system. With Flexeserve's hot air recirculation system using convection, air is heated to a temperature that prevents the packaged cooked food from cooling. We keep the energy put into the food during the cook process within the product in order to maintain food temperature. Products within each zone are surrounded by hot air, programmed in accordance with the temperature requirements of the products being hot held. External effects are hugely detrimental to other heated displays, whereas our units react immediately using their responsive temperature control per zone. In addition, the tight air curtains, the insulation within the shelving of the unit, and the double glazed side panels all enable Flexeserve Zone to function effectively directly next to refrigerators or in colder environments. So, each of the zones can be controlled independently, adjusting temperature as required, and even turning specific zones on and off to suit different trading patterns throughout the day, meaning you only ever use the energy you need. The ability to set the temperature of each individual zone is vital if you want to introduce new food categories, such as a warm bakery program, soft poached eggs, or a delicate rice dish. This all goes towards making Flexeserve Zone an incredibly energy efficient way to sell hot food throughout the day. And as we all know, the higher the energy efficiency, the lower the operational costs. This is why Flexeserve Zone represents flexible merchandising with true hot holding.